Hi everybody. In this video I would like to explain the concept of AC through pure inductance alone. This topic is related to fundamentals of AC circuits. At the end of this video you will be able to explain the behavior of inductance connected across an AC source, identify the expressions for voltage applied, current and power for inductive AC circuit, and analyze the vector and phasor relation diagrams between the voltage applied, current and power for inductive AC circuits. Before going through the topic, I would like to explain what is inductance. The inductance is the property of a material by virtue of which it opposes the change in current passing through the conductor. It is denoted by the letter L, and the symbol for the inductor is like this, and the units of inductance is Henry. Then coming to the topic, the inductance connected to AC source. This is the inductance. It is connected to the AC source. I am considering the instantaneous value of voltage, that is V is equal to Vm sin omega t, that is applied to the circuit, and the current is passing through the circuit. Here I am considering or applying the voltage V is equal to Vmax sin omega t. The back EMF is produced due to the self-inductance of the coil, and that back EMF, that V is equal to L into di by dt. Consider the expression as 2. Substituting the value of V in equation 2, you will get the expression as Vmax sin omega t is equal to L into di by dt. Here Vmax sin omega t is equal to L into di by dt. I am simply rearranging this expression as I am move this L to this side, that is we are getting the expression as 1 by L Vmax sin omega t is equal to di by dt. Then after the rearrangement I am considering, that is Vmax by L sin omega t is equal to di by dt. I am considering this expression as 3. Then after I am considering the integration on both the sides. The integral of Vmax by L sin omega t is equal to integral of di by dt. I am applying the integral to this expression. We are getting here I is equal to Vmax by L minus cos of omega t by t. Here the sine of omega t, the integral part of the sine of omega t, the value is minus cos omega t by t. I am rearranging this expression as I is equal to minus Vmax by omega L into cos omega t. In this expression I am represented this cos omega t as sine of omega t minus pi by 2. I am considering this expression as 4. Here in this expression 4, this sine of omega t minus pi by 2 is equal to 1. We will get the maximum value of current. That maximum value of current is equal to Vmax by omega L. Then fourth equation becomes, by substitution of these, I max is equal to Vmax by omega L. This fourth expression comes as I is equal to I max sine of omega t minus pi by 2. I am considering this expression as 5. From the equation 1 and 5, V is equal to Vmax sine omega t and I is equal to Imax sine of omega t minus pi by 2, we observed that in this first expression, V is equal to Vmax sine omega t, and in the second expression, I is equal to Imax sine omega t minus pi by 2, the difference in that value is minus pi by 2. That means the current value is lags the voltage with an angle of minus pi by 2. See here, the current lags behind the applied voltage by an angle pi by 2. Regarding the vector representation, I am considering the voltage as the reference and I am considering the current value. By the observation of these two expressions, the current lags the voltage by an angle of pi by 2. This V as the reference, the current lags the voltage by an angle 90 degrees. Then coming to the phasor representation, the angle between the voltage and current is pi by 2 and the current lags behind the applied voltage by an angle pi by 2. Regarding the phasor representation, I am considering the time axis on the x-axis, and on the y-axis I am considering the voltage and current. The voltage applied V is equal to Vmax sine omega t and the current is lags the voltage with an angle of pi by 2. See here, the voltage axis, it is this particular value is pi by 2 and this particular value is pi and this one is 2 pi, and the current value, it is lags at an angle of pi by 2 to the voltage. Then coming to the expression for the power, the instantaneous power P is equal to Vi. Already we are having the expressions of V is equal to Vmax sine omega t, I is equal to Imax sine of omega t minus pi by 2. I am substituting these two expressions in this instantaneous power P is equal to Vi. Yeah, I am getting the expression as Vmax sine omega t into Imax sine of omega t minus pi by 2. I am rearranging this expression. I am getting the expression as Vmax Imax sine omega t. This term I am written it as minus cos omega t. Then by the further rearrangement, I am getting the expression as minus Vmax Imax sine omega t cos omega t. This is the expression is looks like as sin A cos A, and we are getting that we are having a formula sin A cos A, that is sin 2A by 2. The A term is that is omega t. So we are getting the expression as sin 2 omega t by 2, and the final expression for the further simplification of this minus Vmax Imax sine omega t cos omega t, I am getting the expression as minus Vmax Imax sine 2 omega t by 2. For the further rearrangement, I am getting the expression as minus Vmax Imax by 2 sine 2 omega. Therefore, the power for whole cycle, see here, this minus Vmax Imax by 2 sine 2 omega t, this one is the instantaneous power. At an instant, at every instant, at any instant, we are getting the power value P is equal to Vi, that is equal to minus Vmax Imax by 2 sine 2 omega t. Therefore, the power for whole cycle, for one complete cycle, that means we are applying the integral part for 0 to 2 pi. See here, P is equal to minus Vmax Imax by 2. This is the constant term, and I am applying here the integral of 0 to 2 pi for the complete cycle, for the whole cycle, sine 2 omega t dt. This particular value is equal to 0 watts. Why this value is getting to be the 0? And I am giving a justification here, that is as by the consideration of the phasor representation, see here, I am considering the x-axis, the time axis, and the voltage and the current on the y-axis. I am applying the instantaneous value of voltage V is equal to Vmax sine omega t, and the particular angles, that is, this value is the pi by 2, this is the pi, and this one is the 2 pi. Here this particular value is applied to an inductor. Regarding that inductance value, we are having a lagging behavior of the current value. It is the lagging behavior of current value, that is of pi by 2 angle. The current value I is equal to I max sine of omega t minus pi by 2. Here, by the observation, this one is 90 degrees and this particular point is the 180 degrees, and going on, this one is the 360 degrees. I am considering for the 90 degrees axis, before that 90 degrees axis, here the voltage value is positive and the current value is negative. The 90 degrees, the voltage value before the 90 degrees, the voltage value is positive and the current value is negative. Because of this one, the power value P is equal to V into I. By the further simplification, that we are getting the power value is negative. This one is the power value is negative because of the positive of the voltage and the negative of the current. We are getting the negative power value. Then after the 90 degrees to the 180 degrees, we will observe that the voltage value is positive and the current value is also positive. So the power value is positive. Okay. Here, for 1/2 cycle, the resultant of the power value is getting to be the 0. The power value, this one is the negative and this one is the positive, is getting to be the 0. So the maximum value of instantaneous power is P is equal to Vmax I max by 2. Then coming to the conclusion of this topic, that is inductance connected to AC source. The current flowing through the pure inductance is lags with the applied voltage. The phase difference pi is equal to 90 degrees. The power factor cos pi is equal to 0. The maximum value of instantaneous power is P is equal to Vmax I max by 2. Thank you.